Chapter 12, Section 2. But actually, before we get to Section 2, I want you to look in your book on page 839. Even with the amount of time we have left, we're limited and we can't quite cover everything in this chapter, but I want to talk briefly about Section 1. And some of you may be very interested in kind of playing around with some of the ideas there. It's dealing with sketching shapes, particularly if you are interested at all in the field of architecture. Remember when Mr. Harris was here and he showed a side elevation, and some of you, I don't remember who it was, anybody in here went up and built a house from the plans or whatever it was? But you have to be able to take a perspective drawing and figure out what is that 3D shape that comes from it there. And on page 839, they're showing what is called an isometric view. You have a 3D object, and you take a corner of it right there, and then draw the rest of it on 2D paper, which is the only paper that we have available to us, that 2D kind, that flat kind right there. So you can see on 839 a way of doing that. Turn to the next page, 840. Often you will see a one-sided view of an object. And what they're giving you in their example 2 is a one-sided view. And then they go another one-side view. They show you the top, then the left, and the front, then the right. And can you interpret the 3D object that comes from it? And then they gave the example that comes from those 4 side views of the object. Another thing we'll have to be aware of under part 2 there on 840, when we take solid objects and we slice through them, what is the shape of that slice when I slice through it? So they show this pyramid there, and if we do a horizontal cut on the pyramid, what is the shape of that slice? The rectangle. If they take that angled cut, what's the shape of that slice? Well, it's a rectangle on that one as well. Well, no, that'd be a trapezoid, wouldn't it? Very good, Adrian. Vertical cut. What shape is that one? We've got a triangle out of it. So that first section is kind of looking at two-dimensional views of three-dimensional objects. Turn to page 842. And you can see where they have done several of these objects, 16 through 19, and then they have this slice through them. And can you visualize the shape we get with those slices? So looking over that's a good idea. We won't have any homework on that, but it gives you a perspective of these three-dimensional things. All right, over on section 2. That's where we will start, what you need to make sure you learn. Three-dimensional objects, and we need to have some specific terms that we all understand what we are meaning, and you may refer to the blocks that I have sitting on the table here to see the three-dimensional object that's drawn on the board. Lateral faces. When we talk about the face of a three-dimensional object, we're talking about a side of it. And if we say lateral faces, we're not talking about a side that can be referred to as the bottom or the top of it, but around the edges, these sides. These are called lateral faces. So when we talk about lateral areas, we're going to be talking about these areas right here. These are lateral faces. And so the lateral edges are going to be these edges, not these up here. These edges right here are lateral edges. Altitudes of objects. Altitudes are the same definition we've always had. We need to go from a point perpendicular to the base, to another side. That's going to be the altitude. And right over here they have shown a right prism, which is what I'm holding, a right prism. And so an altitude is going to come right down a lateral edge. That would be an altitude of this shape. But if it's an oblique prism, it is not perpendicular between the lateral edge and the base. It is off at an angle that's not 90 degrees. The oblique prism, then our altitude has to be sure to be drawn perpendicular to where that base is. So let's look at all these definitions that they have. We have lateral faces, we talked about, lateral edges, we talked about. So these are bases, and it has a base edge over here to go along with the bases. How do I tell what are bases? You might say, well, it's obvious. Just look at it. You can tell what the bases are. But what if I turn this and set it on its side? Can I call this a base now? You may be tempted to say, well, sure, I can call anything a base. Not in the three-dimensional figures that we have, these three-dimensional solids or prisms that we are working on. To be a prism, the base is going to be the shape that if you can imagine a cookie cutter, and I have a big glob of clay, and if I took a cookie cutter, the shape of the base, and I pushed it all the way through my clay, then it would cut out the shape of my prism. So that base has to be able to push all the way through. So, can I call this the base now? If I shoved this all the way through, what shape would I get? If I took that shape right there, I would get a rectangle. If I took that and shoved it all the way through, I would have one of these things. A rectangular prism is what I would get. So identifying the bases is going to be the shape that if I pushed it through space, it would cut out the shape like a cookie cutter. And so this is going to be a base, and that's going to be a base to it. Lateral areas. Let's see if we can come up with a formula for lateral areas. Here they have taken a triangular prism. Now up here we would call this, what shape is the base? It's a hexagon. So I have a hexagon right over here. This is a hexagonal prism. We take the shape of the base to name our prism. So this is a what type of prism? Triangular prism. If I want to find the lateral area, I know that's the sides, nothing to do with the bases. So if I took this and I cut along the lateral edges so that I could open it all up and unfold it, we have what is called a net. And if you look in section 1, you'll see nets referred to. This is called a net. Not going to catch any fish. It is a net drawing from geometry. And the blue shaded regions are all the lateral faces that they have now opened up. And the white outline, those are my bases. So what shape did I get when I laid out in a net the lateral faces? A what? A rectangle. How do I find the area of a rectangle? Base times height. And if I want to know the base, well, it would be A and B and C. Look back over here. If I add A, B, and C all together, what would I call it in the original prism? Perimeter. I'd call it the perimeter. And when we say perimeter, we say the perimeter of the base. And the height is the height. So if I want to know the lateral area of it, they've worked through it, what we were just talking about, there it is. I want you all to have a separate piece of paper that is going to be kept as notes in this whole chapter. And I want you to write down 2 columns. On the left-hand column, shall we get the name? Prisms. We'll give it the name Prisms. I don't know if I want to do that. Let's call it, don't call it any title. Column 1 and column 2. But there are going to be 2 distinct groups of formulas that we are going to be learning. The first group deals with polygons. Maybe that would be a way to do it. The second group deals with when we have circles. So it's not specifically polygons and circles, but those are kind of the 2 areas that we are going to be dealing with. And we are going to have a group of formulas that will be real important in this chapter. Kind of like the last chapter, there were a group of formulas. We're going to have a few more this chapter than the last chapter. And the very first formula we have is, and there will be all sorts of subheadings. And the first one is a prism. Capital L equals capital P H. And you need to understand that in this book, capital L means the lateral area. the area of the lateral faces. And that capital P, you know what that is, we just said it. Perimeter. Means the perimeter of the base, and H is the height. Now we need to make sure we know the height. Our height is very similar to the parallelogram height, or the trapezoid. Let me change it to the trapezoid height. It's going to be the distance between my parallel sides on a trapezoid. And on my prism, it's going to be the distance, the perpendicular distance between the bases is going to be my height. So our very first formula there is for the lateral surface area of a prism. Did we say it only works on a triangular prism? No, we used the triangular prism when we were doing it, but it works on any type of prism. We didn't even say it had to be a right prism. We said, hey, an oblique prism. It will work on that as well. It's easier to visualize this right prism if I made a net, cut down a lateral edge, and unfolded all the faces, lateral faces. You could see that that also would be a big rectangle, where the base of that rectangle is the perimeter of the base of that prism times the height of that rectangle. Find the lateral area of the prism, round to the nearest tenth. So in your mind should pop in our first formula we learned today. Lateral area of any prism is perimeter times height. And so, how about my perimeter? Am I ready to go? Do I need to do any work? I need to figure out the hypotenuse of that right triangle over there. So if I'm going to get the perimeter of this, I first will have to do some work. 6 squared plus 5 squared will equal that x squared. So I know x is going to be the square root of, what's 6 squared? 36. 5 squared? What's 36 and 25? 61. I'm just going to leave it square root of 61. So I am supposed to take the perimeter, which means we need to, and it's the perimeter of the base, so we need to add up all three of these sides. Well, 6 and 5 make how much? 11, plus the square root of 61, that would be the perimeter. I'm going to put it in parentheses, because we have to multiply the perimeter times the height. What's the height of that prism? 7. Even though it's laying down on its side, 7 is the perpendicular distance between the bases. Now go to your calculators and tell me to the nearest tenth, since that's what they requested us to do. So we won't round until we get our final answer. What number do you get? $65.7? $65.7? Yes. 65.7 centimeters squared. As long as I know my formula and go find all the values that belong in my formula, I have my answer. Second thing to write on that note paper on the left-hand column where we've said prism and we did this capital L thing for lateral area, we want to know the surface area, which means the total surface area, all the surfaces. Well, if I have found a formula already for the lateral surface area, what is left to find the area so that I have the whole thing? The bases. How many bases do we have in a prism? 2 of them. So all we do for this formula, and there's another way of writing it, is say I take the lateral area plus twice the area of the base. Capital B, you need to think area of base. If I asked you the formula for the area of a triangle, you would say 1/2 base times height. What type of B do we write in that formula? A lowercase b. That means the length of the base. When you see here a capital B, that means the area of the base. So it's real important to keep that straight. Write down, and I would write down this formula, the one I did in red, because the lateral area is found by the perimeter times the height. So the surface area, which means total surface area of any prism, is going to be perimeter times height plus twice the area of the base. Now when we say area of the base, well, my base can be different shapes. The one right here in their model is a what shape? It's a pentagon. Here I have a pentagonal prism. So I'm supposed to find the area of this base. How do I find the area of a pentagon? You have to think back to last chapter. 1/2 apothum times perimeter. That's what it is. 1/2 apothum times perimeter. You're going to need to use some old formulas when we're talking about the shape of the base. So it depends on what the shape of the base is. I'll have to figure out, how do I find that area? Well, they start us out pretty basic over here. They say find the surface area, which means total of that rectangular prism. So I am going to immediately think, oh, surface area of any prism is perimeter times height plus twice the area of the base. And I would encourage you to write that formula down every time you do it in your homework problem, because you're memorizing it for the test when you do that. And it's stuck in your head by the time you get to the test. So if I'm going to get the perimeter, what perimeter are we talking about?
9 plus 4 plus 9.
Yeah, we're talking about the perimeter of the base. So right over here is going to be my base. So my perimeter of that base, I could call it 2 times 9 plus 2 times 4. That would be my perimeter. What's my height? 6 plus twice the area of the base. How am I going to get the area of that base? 4 times 9, or 9 times 4. It's just a rectangle. Let's simplify it here a little bit. 18 plus 8 is how much? 26 times that 6 plus 2 times what's 9 times 4? 36. Why don't you go ahead and give me the answer for the total surface area of this rectangular prism using this formula. And that's important to use that formula today. 118? 118 feet square. Why is it feet square? Area. We're going meters times meters, or feet times feet, or centimeters times centimeters. It's area. 228? Oh, 228. Sorry, 118 has been rejected. 228. 228 feet square. Find the surface area of the triangular prism, round to the nearest tenth. Okay, well we know surface area is, tell me the formula. Perimeter times height. Base area, or area of the base. So again, think area of base. I would not say B when you are doing that formula, because it's too ambiguous. And it will be too ambiguous in your mind when you go to do these problems, either homework or test time. But when you say area of base, we know exactly what we're supposed to be doing. I need to identify the base, because that's involved in the perimeter and the area of the base. What's my base of that picture over there? It's the triangle right there. How do I know that's the base? That's the shape that if I pushed all the way through the figure would make that prism. Why can't I call this 12 by 8 rectangle down here on the bottom of the base? If I push that rectangle up, do I get this shape? No. You would get a rectangular prism if you push that one up. You would get one of these things if you push that base up. So I need to make sure I identify what the base is. So now when it says perimeter, well, what am I needing to get? That triangle. I need to get this hypotenuse. Can you quickly tell me the answer? 12 square roots of 2. Where did you get that 12 square roots of 2 from? This is a 45, 45, 90 triangle. So I have 12 square roots of 2 to add to my 24. 12 and 12 make 24. And that will be my perimeter of the base. 24 plus 12 square roots of 2. Times the height. What's the height of this prism? 8 is the height. That's where I'd have to push all the way through the height, 8 millimeters to get there. Plus 2 times the area of the base. How am I going to get the area of this base? 1/2 base times height. I'm going to use the area of a triangle formula, 1/2 base times height. So 1/2, what would I call the base? 12 times, what would I call the height? 12. Remember, we are talking about the triangle now. This B is the area of the base. So we're ignoring the prism. It's the area of this triangle. So 1/2 of base 12 times height 12. I'm going to do some simplifying. This first one over here I can't do much with. That 24 plus 12 squared is a 2. So we'll go right to our calculators on that one. But over here I can. What's 2 times 1/2? 1. What's 12 times 12? 144. Why don't you go to your calculators and round to the nearest tenth? All of you should be trying this so that you can enter in parentheses and radicals, square roots, all at once in your calculator and make sure you're getting the right answer. So we should get 100% agreement. Right, Wyatt and Tyler? Thanks, gentlemen, for being with us here on this. 471.8? 471.8 millimeters squared. Column 2. I said 2 columns. Left-hand column, you only have 2 formulas right now, dealing with the prism. Now, on that piece of paper on the right-hand side, we're going to have some formulas in just a minute dealing with cylinders. So we want to know about lateral area and surface area of cylinders. Make sure we can get some proper terms that go along with it. So here's a cylinder. You might say, oh, that's a tube, or that's a can. Several things are cylinders. We have as a base what shape? A circle. So there's a center to that circle. And if I connect the line between the centers of the 2 circle bases, that is called the axis of the cylinder. Now, the axis of that cylinder, that's the axis on that oblique one over there, is not necessarily perpendicular to the base. But if it is, then the axis is also an altitude, and it means it's a right cylinder. If that axis is not perpendicular to the base, then we have an oblique cylinder, and it's not the height. To get the height, I need the perpendicular distance between my 2 bases. So the height or the altitude of it. So here's that word axis. It connects the centers of the 2 circular bases. So let's look at the net for a cylinder. If I sliced it, just like if you had, maybe you saved labels when you were younger to turn in, forget a half a penny a label or something like that. You slice down the side and you open that label all up, and once again, what shape is that? Lateral surface. That is a rectangle. And the height is the height of that cylinder, but the base now is the same distance as was around that circular base, which is called what if I go around the circle? The circumference. And we know the circumference is found by 2 times pi times r. So if I wanted to find the area of this rectangle, I would get this whole base, which is 2 pi r, times the height. And there is going to be our first formula. The lateral area for a cylinder is 2 pi r h. Now, if you line it up on your 2 columns, so it lines up with the lateral formula for the prism, I want you to notice that those are the same things. If I'm going to come to a blank page. Let me give myself a blank page. If I look at that prism, it was perimeter times height. If I look at the lateral surface area for a cylinder, it's 2 pi r times height. What does 2 pi r equate to, or the same thing as, over here in this left side? The perimeter. 2 pi r is the perimeter of the base. We call it a circumference when we're talking about a circle. So really, it can help you remember in your mind, there's one formula that fits both of them. It's the perimeter of the base times the height. It's just if my base is a circle, that perimeter is called circumference, found by 2 pi r. So when you have these 2 columns, we're going to notice a lot of similarities that way. How they match up left to right. on these different formulas we see. And here's my surface area formula. Like before, it's the lateral area plus twice the area of the base. And we know the lateral area for a cylinder is 2 pi RH plus twice the area of the base. Where did pi r squared come from? Area of a circle is pi r squared. So I know the specific formula for the area of this base. Cylinders always have circular bases. Find the lateral area and surface area of the cylinder. Round to the nearest tenth. So lateral area, I know it's 2 pi RH. Write it down again. Every time you do that in your homework, you will begin to memorize that, and then it sounds familiar and you know exactly what to do. 2 times pi times, do I know my radius? (7.5). Make sure you identify what the radius happens to be. Times the height. What's my height? 18. Run that through your calculator because they say to the nearest tenth. We could get an exact value, but they say to the nearest tenth. I really want everybody working with me. Some of you are so interested in just doing homework, I could just be quiet and let you guys work all on your own. But I don't want to do that. I want you guys to be participating in the instruction, so you are very solid on that. How much? 848.2? 848.2 millimeters squared. If I am going to find the total surface area, can you repeat to me the formula for a cylinder? Total surface area. 2 pi, I think I heard it, RH plus 2 pi r squared. Again, write it down every time, say it mentally, and you're memorizing it. And you want to do that this chapter because we're going to have a list of formulas. So this will really help you in getting our answers. Now, when I do 2 pi RH, I know that already, don't I? Do you still have this in your calculator or not? Tell me what it is to at least 2 decimal places, because they want the answer to the nearest tenth, but I've already rounded this. 23? 848.23. Plus 2 pi times my radius, which is still 7.5 squared. Why don't you enter this in? Even better would be to go back to the original and say 2 pi times 7.5 times 18 plus 2 pi 7.5 squared. Then when I round, I know I'll get precisely what they want. Say that again. Yes. 1,201.7 millimeters squared. Tree. Use the rectangular piece of felt shown at the right to cover the curved surface of her cylindrical pencil holder. What is the radius of that pencil holder? Think about that a minute. What do we know in that figure that can help us with the radius of the pencil holder? We know what? I know the circumference. What's the circumference? 12.6. When I wrap this around my circular pencil holder, that's the circumference right there, 12.6. And what is the formula for circumference? Okay. True. We're looking for the radius, so can you give me another formula? 2 times pi times the radius. So what would I do to get that radius by itself? Divide by 2 pi. So you tell me, what is the radius? And see if you can divide that properly. .0, nearest tenth. That is a very reasonable sounding answer. Some of you maybe are not getting 2.0. Some of you are getting something like 18. The reason you're getting 18 is you're not dividing by pi, you're multiplying by pi. Your calculator isn't smart enough to know that that's both in the denominator unless you tell it. Otherwise, all you're doing is taking 12.6 and dividing by 2, which is 6.3, and then you're multiplying that by 3.14 by pi. That's why you're getting your 18 or 19 answer. So make sure that you're smarter than your calculator so that you get this number. All right, let's go to the work that we do. So now is a good time to be writing stuff down. On page, where are we? 849. Number 1. So find the lateral area of this prism. L equals, do you have it memorized? pH, perimeter times height. So we're not in chemistry. That's not power of the hydrogen. This is perimeter times height. So if I look at this figure here, my perimeter, what are we going to do to get the perimeter? 4.5 times 5. I'm going to write it down that way. 4.5 times 5. That's going to give me the perimeter. How about my height? 5. So I can just take as is and multiply it together and round to the nearest 10. 112.5 inches squared. And I'd encourage you just to write it all down and then go to the calculator as the last step to do, not get little pieces along the way. Number 2, they want to find the lateral area and surface area of each of these prisms. Well, I know, 2, lateral area is still perimeter times height. And again, write it down, write it down, write it down. That's how you memorize. So how about my perimeter? How are we going to get the perimeter? Maybe I should ask, where's the base? Oh, they gave a base with an arrow. That's terrible. How am I going to get the perimeter of that base? 2 10s plus 2 11s. I'm going to write it that way. I have 2 10s plus I have 2 11s. How about the height? 15. I might simplify this a little before I went to a calculator. 2 10s are called 20. 2 11s are called 22. And so you might even call that 42 times 15. How much? 630 meters squared. They want the surface area. Do you remember the formula? Surface area, which means total surface area? Perfect. Perimeter times height plus 2 times the area of the base. Now we have an exact answer, 630, for our lateral. So there's no rounding there. Plus 2 times the area of the base. How will we get the area of that figure? 10 times 11. 10 times 11. Total surface area. $850 meters squared. Number 3. Lateral area, perimeter times height. Now I know I've written that before, but I'm going to keep writing it. And I'll try to quit emphasizing that. But that's so important. You memorize it this way. Where's our base? We need to identify it. That triangle over there is our base. What I often will do is I will draw out my base, even if I'm not drawing my whole picture. I need to know my base. And this happens to be a right triangle with an 8 and a 6. So if I'm going to get the perimeter, 10. Where did you get 10 from? This is a 3, 4, 5 triangle. Just been doubled. So that is going to give me a perimeter of, what's 8 plus 10 plus 6? 24. And what is going to be the height of this one? 12. Answer for lateral area? 288 feet squared. Surface area. Well, I know it's perimeter times height plus 2 times the area of the base. And I have an exact value for lateral area of 288, so I'm going to use it. 2 times, how will we get the area of this base? Okay? I'm going to write it as 1/2 times base, 6, times height, 8. Again, that's why I like my picture of the base drawn, because I often have to work with that base. 288 plus 48, because 2 times 1/2 is 1, 6 times 8 is 48. What do you get? 336 feet squared. Number 4. Evan is buying new tire rims that are 14 inches in diameter and they happen to be 6 inches wide. Determine the lateral area of each rim and round to the nearest tenth. What kind of shape are they talking about, these tire rims? Cylinders. That's what he's talking about. Cylinders. Now mine's kind of long, but here it is. Here's his tire rim. He's got the rubber tire around the outside of it. So he wants to know that lateral area, this area right over here. What's our formula for our cylinder? 2 pi RH. There it is. So I can take 2 times pi. Do I know the radius? How much? 7. It says his rims are 14 inches in diameter. That makes a 7-inch. How about the height of it? 6. He's talking about how wide it is 6. Well, that's really the height of the cylinder we're talking about, is 6. Now, before I go to a decimal, tell me what 7 times 6 is. Times 2. 84 pi is the exact answer, but if I went to the nearest tenth, what do you get? 263.9 inches squared. Like last chapter, be able to get those exact values. They're often much easier, in fact. You don't even need a calculator, and you know exactly what it is. 5. Find the lateral area and surface area of these cylinders, and they want us to round to the nearest tenth. Okay, well, lateral area we know is 2 pi RH. 2 times pi, do we know the radius of this one? 13. How about the height? 8. Again, I want to go through the exact answer. I'm going to go 2 times 8, which is 16, times 13. Okay, if you need a calculator. 208 pi. And now I can take that 208 times pi and get approximately 653.5 yards square. So we want to get the surface area. Well, I know that's 2 pi RH plus 2 pi r squared. Now the lateral I just found, and I'm going to use the exact 208 pi. That's not rounded. Plus 2 times pi times 13 squared. I'm going to go through the exact again. What's 13 squared? 169 times 2, 338. So if I have 208 pi plus 338 pi, that's how many pi's? A lot. How many? 500 and 546 pi's, which is a lot. Approximately 1,715.3 yards square. That kind of ruined your diet, those 546 pies. Number 6. No, nobody laughed. Lateral area. Okay, we know lateral area is 2 pi r h. So 2 times pi times, how about the radius of this one? 10.2. When they show that line going all the way across, they're referring to that whole diameter when they show the line like that. Height, do we know the height? 22. Now this one has decimals for it. Go ahead and stick it in your calculator. My book claims it's 1,409.9. Is that rounded correctly?
Yeah.
Centimeter squared. Yes, that is what some of you say. Some had some different answers. Total surface area, 2 pi RH. Why don't you just leave that number in your calculator? Plus, how do I finish it? 2 pi r squared. 2 pi r squared. So if I take that number and add, that's why I just leave it in my calculator, 2 times pi times, what's our radius again? 10.2 squared. Then I don't have to worry about any rounding error. Correct. 2,063.6 centimeters squared. So how do I get exactly that decimal? Don't round. So if you keep that lateral area in the calculator, it's not rounded yet. Well, it's not rounded very much. 10 or 12 places, depending on how big the calculator is. Food. The can of soup at the right has a surface area of 286.3 square centimeters. They want to know what's the height of the can, rounded to the nearest tenth. Surface area, they say. What's that formula again? So let's put into our formula what we know. What's that 286.3? That's S, surface area. 286.3 equals 2 times pi. Do we know the radius? 3.4. Do we know the height? No, we leave it as h. Plus 2 times pi times our radius, 3.4, which has to be squared. Now we're going to do some algebra. We're not going to go to a calculator and start trying to get numbers. I want to isolate this h. Can you tell me the first algebra step I would take trying to get that h by itself? Well, I don't need a factor. There's only one h in this whole thing. So we'll start there. Subtract this. This is just a number. Whatever it is, I just need to subtract it. So I'm going to do the same thing over here. So I'm going to start writing 286.3 minus 2 pi times 3.4 squared. I have eliminated that. Now what will I do? Divide by my 2 pi times 3.14. Divide by my 2 pi times 3.4, not 1/4. And that will eliminate this number. And I have isolated the h. Now we need to tell our calculators that this is all in the numerator and this is all in the denominator. So I would use parentheses where I put those red things. Try it out. See if you can enter one time. So no rounding needs to be done except this one answer. All of you try that. See if you can get 10.0. When you round to the nearest tenth, you should get 10.0 centimeters as the answer to this one. If you're not getting that, now's a good time to know I need some help from the teacher, a neighbor, so that you can enter this and get that answer in one shot. That's an ability we need to be able to do. Let's try 8. The surface area of a cube is 294 square inches. They want us to find the length of the lateral edge of that cube. Surface area. What do they mean when they say cube? It's a rectangular prism, but everything's exactly the same size. You know what a cube looks like. It's a rectangular prism, though, is what it fits with. Now, I know this type of rectangle we have is a square down here. So what, again, is special about the measurements in a cube?
It's all the same.
All exactly the same. So we have a surface formula, and just watch for a minute. Rectangular prism. What's the formula? Or any prism. What's the formula? Perimeter times height. Twice the area of the base. Now, I am going to, well, let's use x for the length of a side, I guess is what I'm going to do. So here is my prism. Use your imagination. There's my prism right over there. I'm going to call x. And I know every single one of these things are x. What would be the perimeter of the base? 4x. What would be the height? X. Plus 2 times area of the base. X squared. X times x. Or x squared. So I would have, well, what's 4x times x? 4x squared. Plus 2x squared. What does that equal? 6x squared equals my surface area. So we just figured out, I should have told you to write. We just figured out a formula for the surface area of a cube when I call a side x. Usually we'll call a side s. So when they tell me, I know a lot of you should be writing, that the surface area is 294 square inches, I can say, 294 must equal 6 times x squared. What would I do with that? Divide by 6, and then take the square root of it. So whatever 294 divided by 6 is, I'm then going to take the square root of it. Is it exactly 7? Yeah. 7 inches. And I am going to get 7 inches. So I started with the formula that works for any prism. And we knew that all the measurements were exactly the same. So we just filled in the measurements into the formula and simplified it. Your assignment from 849. We have 1 through 30. 1 through 8 we have accomplished together.